Hi guys, the question for today is a moving coil galvanometer having a resistance of G produces a full-scale deflection when current Ig flows through it. This galvanometer can be converted into first one, an ammeter of range 0 to I0 such that I0 is greater than Ig by connecting a shunt resistance of Ra to it. Second, into an voltmeter. So they have given basically a conversion of galvanometer into an ammeter and the voltmeter. Okay, and they have specified the corresponding the values also. So based on this we need to solve the problem. Okay, and we need to choose which of the options A, B, C or D is correct. First let us try to analyze the diagrams. So let me bring in the circuit diagram for both the conversions of the galvanometer into an ammeter and voltmeter and so on. Okay, so you can see I have brought in the image, so the figure. So this is basically the figure where the conversion of galvanometer to ammeter happens and conversion of galvanometer into an voltmeter. Okay, so first one is basically when a galvanometer is used as an ammeter, the shunt is used in parallel. So basically shunting happens in parallel here. Let me show it here. So here shunt resistance Ra. So Ra is basically the shunt. Okay, the shunt resistance. You can see conversion of a galvanometer to ammeter. So here it is ammeter. So it's basically the galvanometer is converted to an ammeter here. That is the first one, first image or the first figure, and second image you have the galvanometer is basically converted into an voltmeter. So these are the two diagrams which we need to understand with respect to the conversions. Now, when you convert a galvanometer to an ammeter by shunting in parallel, what happens? The effective resistances are going to be in parallel, right? The galvanometer resistance and the uh, shunt resistance, both are going to be in parallel. So accordingly, when we apply the loop law, we will get the equations as Ig is equal to Ig times G is equal to I naught minus Ig times Ra. Okay, this is what we will get. So now let me find out Ra. Just rearrange for Ra. What is Ra from here? By simple rearrangement, we get Ra is equal to Ig upon I naught minus Ig times capital G. So let me mark this as equation number 1. Okay, this is for galvanometer to ammeter. We have found out the relation. Similarly, when galvanometer is used as an voltmeter, we get the relation as Ig, because both are in series combination, so it is be Ig times G plus RV, where RV is the resistance of the voltmeter. Okay, is equal to G times I naught. Okay, so similarly, let us find out what is RV. Rearrange for RV here. We get RV is equal to I naught minus Ig divided by Ig, the whole multiplied by G. So let us mark this as equation number 2. So we have two equations. According to the options, we need to find out what is RARV. So first multiply RARV and find out the relation. So let us do that. So RA times RV is equal to, so I multiply, that is nothing but multiplying 1 into 2. So let me multiply. So if I multiply that, I can see that G and G is is there. So you will get G square. Okay. And what about I and upon I naught minus Ig and I naught minus Ig upon Ig? Both these terms will get cancelled out. Okay. So it's only G square. So RARV is G square. Okay. This implies RA times RV is equal to G square. What about the other term they are asking? It is RA upon RV, right? So RA upon RV, the second one, let us do that. So RA upon RV, that is basically 1 upon 2. So if I do that 1 upon 2, what happens? In that case, G is going to get cancelled and I will get the relation between I Ig and I naught minus Ig. So we can see that we will get Ig upon I naught minus Ig the whole square. Both will get multiplied with itself. So therefore Ra upon Rv is equal to Ig upon I naught minus Ig the whole square. So according to that, which option is correct? So option B is correct, right? See, Ra times Rv is G and Ra upon Rv is Ig upon I naught minus G the whole square. So option B is correct. Thank you, students. Hi students, the question for today is a thin strip of 10 centimeter long and there is a U-shaped wire of negligible resistance is connected to the spring of spring constant 0.5 Newton per meter. Okay, we can see the figure. Now the assembly is kept in a uniform magnetic field of 0.1 Tesla and the strip is being pulled from its equilibrium position and it is released. The number of oscillations it performs before its amplitude decreases by a factor of E is given as N, and if the mass of the strip is 50 grams, okay, and its resistance is 10 ohm which is negligible, and they're asking us to find out the value of N. Okay, so we should find out what is the value of N. Okay, because it's an MCQ question, we are given with 4 options, we need to find out the correct option. Okay, so to solve this problem, there is a very simple formula that we need to use, which is T naught is equal to 2 pi times under root M upon K. Okay, the K is the spring constant. M is nothing but the mass. Mass is given as 50 grams. Spring constant is given as 0.5 Newton meter. So I'm substituting all those things. Okay, so let me substitute 50 grams. Okay, upon spring constant is 0.5. Okay, so I'm substituting these values, Newton per meter. Okay, so I'm substituting the value. I'm going to simplify as per SI unit. So I'm converting 50 grams to kilograms, we all know that. Okay, and then simplifying, so I will get the value of T naught is equal to 2 pi upon root 10. Okay, this is what we will obtain upon simplification. Now we already know that the equation which relates the amplitudes, you know, A is equal to A naught times E raised to minus T upon gamma. Okay, this is the relation. Now, for A is equal to A naught upon E, the T value is gamma. That is what it means. Okay, let me write down here. For the amplitude A is equal to A naught over E, okay, the T value should be equal to gamma. Okay, so I am writing T is equal to gamma, which is equal to 2M by B. This is the relation. So which is equal to 2M upon, now in the place of B, I am substituting the magnetic field. So relation, so B square I square upon R. Okay, so upon R, so substituting all the values and simplifying, I will get it is 10 raised to 4 seconds. Okay, I will get the values 10 raised to 4 seconds. So therefore I can find out number of oscillations. So number of oscillations T upon capital T naught, so is equal to, that is nothing but 10 raised to 4 upon 2 pi under root 10. Okay, so this value is approximately equal to 5000. So 5000 is nothing but the number of oscillations, no, per time period. So the answer is option C. Thank you, students.
Hello everyone, the question says that the mean intensity of the radiation on the surface of the sun is about 10 raised to power 8 watt per meter square. The RMS value of the corresponding magnetic field is close to. So in this question we have to find out the B RMS value, that is root mean square value of magnetic field. Now we know intensity, that is I equals to epsilon naught C into E RMS square. So now we also know value of ERMS equals to C into B RMS. Now replace this value of ERMS with C BRMS. So we get I equals to epsilon naught C, and here C square, it will become C cube B RMS square. So now on solving this value we get BRMS will be equals to square root of I upon epsilon naught C cube. Now manipulate the value. So after manipulation of the value, it is 10 raised to power 8. This value is 8.854 into 10 raised to power minus 12 into 3 into 10 raised to power 8 whole cube. Now on solving this value, we get value nearly equal to 10 raised to power minus 4 Tesla. So it is a value of BRMS. That is option C. Hence option C is right.